So we wait. Oh, hello. Forgot all your answers. It's okay then. So we wait for 1 more minute to start. Okay, maybe just get started. So how are you feeling about this paper? I thought it was harder than last year. We need to send this link to the other WhatsApp group. I don't know. So few students in YouTube. I see many students in the WeChat already. So actually, so for last week's RMO, by the way, the RMO difficulty is closer to last year and it may be easier than last year. This is RMO. But for SMOPs, obviously, it's more difficult. It's more difficult. So the estimated score, passing line might be maybe 90 point, and maybe just 90 point, right? So let's check about questions, and then because we have 30 questions to go, so we may go faster than the RMO ones. So the first question, right? This is an easy one. So just the 1200, right? So the length increased by 10%, and the width decreased by 20%. Or if you, so now the answer should be 1056, right? The first question is easy. Yeah, first question is easy, right? And then for the second question, so we want to make p squared plus n for any prime number is not a prime. So generally when we see the word prime number, right, and mentioned a lot of times, we should think of a parity first, right? So the odd and even. So obviously, as long as n is an odd number, then all the odd plus odd makes it an even. So as long as n is an odd number, it can make every prime number except for 2. The sum of this is not a prime number. So the only problem is, so what is smallest n? Smallest odd number to make 2 squared plus n a prime. So now 2 squared is 4. So 5 is prime, 7 is prime, and then so 9 is not prime. So now the minimum value is 5, right? Is this one easy or difficult? Easy. Yeah, I thought it's easy. Right. Okay, so then the questions read the concentration problem. So you can use the algebra or maybe concentration cross. I prefer the concentration cross, but if you don't know how to use it, just the algebra would work. So we mix 10% and 40% into a 20%. So use the concentration cross, we just calculate the difference of concentration. So this 10% and 20%. So the concentration difference ratio is 2 to 1. So now the total volume ratio, or maybe the weight ratio, this volume ratio is also a 2 to 1. And since the total is 300 liters, so now the 10% should worth for 200 liters, and this worth for 100 liters, right? So the answer is 200, also easy question. So far, the first 3 questions is easy. Question 4, right, actually is also easy. So first, it's the February 29. So we should know that every 4 years, we have a gap year. And the only gap year have the February 29th. And so now we count the time by every 4 years as a pattern. So now in this 4 year, we passed 3 normal year and 1 gap year. 365 have remained 1 divided by 7, and this is 2. So now, it's every past 4 years, actually the day for the same date passed by 5. So if you want to make it to be the Thursday again, right? From one Thursday to another Thursday, and the day passed must be a multiple of 7. So now because every 4 years the remainder is by 5, we need 5 to make multiple 7. So now we should pass 7 of 4 years. So it's the 7 times 4. About 28 years passed, so we can meet another. Then we plus the 2024. So it's the 2052, right? 2052. So easy one, also easy one. Question 5, you would see that the 25 is not easy. 25 is not easy. So you may be able to find the pattern here. So if you list for a while, 1 is the special number, 2 is special number, 3 is not. And then 4 is special, 5 is special because 1 to 4 is 7. And 1 to 4 is 12, so now 6 is not. And then 7, 8, and then you will find out is that 9 is not. Then we find 10 and 11 both are, and 12 is not. What is the pattern? So can you find the pattern here? So the pattern is, so every number except for multiple of 3. Right? They are all special numbers. So now if this pattern is correct, we can easily find out the answer because the 20 is special number. So every three number we have 2. So 20 divided by a 2/3 is 30. So now the answer would be 29. Right? So just the number before 30 is 29. So this question, should it be easy or normal? So it's just about your bravery. So if you're brave enough to find a pattern and guess, yeah, you can find out the answer, but then how to prove it? So the problem is how to prove it. It's not that easy to prove, by the way. It's not that easy to prove. So yeah, maybe I label it easy. So we don't have the time to explain the proof here. So do we have? The proof is based on mathematical induction. You can use the mathematical induction to prove it, but not all the primary school students know what is mathematical induction, right? If you are in my elite class, right? So now if you are in my elite class, you can try to use the mathematical induction I told you to solve this question. If not, maybe just leave it to be. So there are so many questions in this month's history also, right? So some questions that you are easy to find out the pattern and then solve the problems, but then it's not that easy for you to prove it. It's not easy for primary school students to prove it anyway, right? So this is the question 5. Then question 6, right? Question 6 is the similarity model is the easiest because this is the 8 and 16. So now the ratio here is 1, 2, 3. So also, so this ratio here is also a 1, 2, 3. So which means this is m, this is n. So now we get the mn over ad, also a 1, 2, 3. And then which means the triangle FMN should be 1/3 of the triangle EFG. And hence the shaded region would then be 2/3 of the triangle EFG. And for triangle EFG, the base is the 24, the height is the 8. So now half times 24 times 8. So the answer is 64. But this is also an easy question. But for the previous one, yeah, should I label it be easy or normal? Easy or normal? I don't know. So maybe easy. Maybe easy. Just brave enough. Or maybe label it be normal because you need to be brave. You need to be brave anyway. Right. So the pattern finding. Yeah, in primary school, you just use the pattern findings for it. And then so yeah, regardless of others. And then question 7. So now the product of two positive integers equal to 10 times of the sum and then equal to 15 times the difference. So maybe the algebra is the easiest way. So a plus b equal to, so because 10 times of product, so now equal to 10 times of ab. Then a minus b would then equal to, no, it's 1/10 of the ab. And then, so this is 1/15 of the AB. So the easiest way is that you just use this formula to solve out the A and B. So how to solve this A and B? So we just adding the sum and difference together, we get the 2 times of A, right? So 2 times of A is 1/10, 1/15. And also we find the difference is 2 times of B. Use the sum and difference to get expression of A and B. So now we get A would equal to 1/12 of AB. And then B equal to 1/60 of AB. So we cancel out A and B here. So we can get A being 60 and B equal to 12, right? This is also an easy question. The sum of these two numbers is 72, right? Then the question 8. Oh no, my WeChat dropped. So I need to rejoin it. Yeah, maybe for a while. Okay. So yeah, where are we? Okay. So question 8. Question 8 is also easy, right? So you just know that the total distance we label it to be the 1. So now the speed for Tom is 1/21. Speed for Jerry is 1/28. So now the meeting time is the total distance divides the sum of their speed. If you calculate this, you find out this is the 1/12 for their sum. And then after that, so they meet each other's meeting time. After they meet, they go back to Jerry's house at Jerry's speed. So ignore the Tom. So only look at the Jerry. So Jerry come from his house to the meeting point, then from meeting point to go back to his home, which means the time for Jerry should be exactly the same. So now we just simply times the 2, right? The meeting time is the same as the returning time. So now times the 2. So the answer should be a 24. Okay. So far, so easy. Okay. So then the question 9. Find the smallest positive integer so the sum of all its prime factor is equal to 2025. So now the logic is, if we want the sum, so we know the sum of this factor are constant. We want to make the smallest number, right? We want to make the product the smallest. And then we should make the largest difference for them, because we have constant sum. And so we want to find the largest difference, which means we need to find the large number should be as large as possible. So now, what is the largest prime number close to 2025? It's the 2017. So anyone knows that 2017 is a prime number. So now, yeah. So if you are born in the 2016, 2017, maybe if you take the test that age, so you would obviously know that 2017 is a prime number. But then not everyone knows 2017 is a prime number. But if you don't, you can just try it. Try the of course 2023 is not prime. 2021 is not prime. If 2021 is 43, 47, and 2019 obviously multiple 3. So now to go to the 2017, right? Just go to the 2017, right? So now 2017 is the largest prime factor we can use. So now we remain is the 8. So how to split this 8 into the sum of prime numbers? So just 3 and 5, right? 3 and 5. Yeah. So this is the way. This is the way. By the way, so I just wonder. So the sum of all its prime factors. So I suppose that this description. I suppose that this description is something not that accurate, because, right? So yeah, so for example, the 12 equal to 2 to the power of 2 times 3. So what is the sum of all its prime factor? It's 2 plus 3 or 2 plus 2 plus 3. Which one do you think is correct? Which one do you think is correct? So I don't know. So I think both would be okay. But does it make any difference for this question? I think no, because if you separate this, if you want to separate 8 into the sum of, for example, if you separate the 2, 2, 2, 2, or maybe 2, 3, 3. So actually you will find out that this product here is larger than 3 times 5. 3, 5 is only 15. This is 16. This is 18. So actually, I think it makes no difference here. So the final answer should just be the 2017 times 3 times 5. So 2017 times 15, right? So it's the final answer. So am I too fast? I don't know. So I think this is regular speed. So if you cannot catch it up, you can watch playback afterwards. So what is the final answer, by the way? What is final? And I need to check. So I did this question. So maybe let me check. I don't want to calculate it. I don't want to calculate it again. So well, what is the answer for this? 30255. 30255. This question is not easy. Let's suppose it's a normal question. Since, right, not all of you know that 2017 is a prime number, right? So yeah, just about the prime number stuff. Question 10 is easy. So generally just unify the unit by the ratio given here. So now the S1, S2, S3, S4. So, but we should do it step by step. 5, 4, 7, 8. So maybe unify it here. The first step, we unify it here. So it's 1, 2, 3. So make it into 28. And then this is 35. This is a 32, right? Then again, it's a 9 to 7. Unify the 1, 2, 3, 4 again. We times a 9. So which makes it to be, maybe I just quote my answer. I don't want to calculate it again. So I calculate all the questions to give out the solution before this live stream. But again, some method may not be that good. It's actually not that good for you. So I try to use the best method here for you to get it, maybe. So it's not my problem more. Right. Okay, so the total would then be 1079 unit happen to equal to 2158. You don't need to calculate, obviously u equal to 2. Obviously u equal to 2. And then we want to know the secondary one. Secondary one is the 630. Yeah, 630. So now for the 4-point question, so the first 10 questions, 4-point question, right? We have most of them are easy questions. So 8 easy questions and 2 normal questions. It's not that. So you see, this already suggests that this paper is difficult because in the past years, all the first 10 questions should all be easy questions. But now we already have 2 normal questions here. So how many do you get correct for the first 10 questions? I don't know. So I think you should get at least 8 questions correct. You should get at least 8 questions correct for the first 10 questions. Okay. So if you have lower than 8, then I think the hope for you to enter the second round is very low because the 5-point, 6-point question is more difficult than ever. Okay, then move on. So question 11, right? So we want to know that 4900 minus p is a perfect square. So 4900 minus p equal to k squared. And you should notice that 4900 itself is also a square number. So it's 70 squared. So we rewrite it in this way. So 70 squared minus k squared equal to p. So which is 70 minus k, 70 plus k equal to this one. And then the problem is, so how to make this work? So if p wants to be a, you see, so if p wants to be a prime number, so 70 minus k must be 1. The one number must be 1. And then another number must be the number we need. So which means in this case, so we must make k equal to 69. And then p would then equal to 70 plus 69 is the 139. So now the only problem is 139 a prime number or not? Is 139 a prime number? So this is the only possible way to make it to be the prime number. So we need to check. But gladly for us, right? So this one is prime. It's not a multiple of 2, 3, 5, 7, or 11. So this is a prime number. So we have one number here. Only one. So this question, easy or normal? Easy or normal? Vote. This question is easy or normal? Yeah, maybe easy or maybe normal. I don't know. Maybe I make label easy here first. And then we can move on. Question 12 is easy, obviously. Question 12 is too easy. Yeah. You think it's normal, right? Most of things normal. Then maybe no normal. Maybe normal. Yeah. Maybe normal. Normal. Right. Okay. So question 12 is easy, right? The ratio between all this one is 1u, 3u, and 5u. So we just use the 27 divides 3 times 9 is the 81. This is the easiest. So this is an easy question. So no doubt, right? So then the 13. I remember 13 is old question. I remember I see this question at least twice in the past year paper, but I just don't remember is it the RMO question or the small question. But I remember this is an old question, but still also easy. So generally speaking, you just need to know that how many faces can you see? So when you make a 3 times 3, right? So now we have 8 on the corner, 12 on the edge, and then 6 inside the center of the face. And also we have 1 inside of it, right? 1 inside of it. Yeah, I remember this is a small question, right? So now for the corners, we can see 3 faces. We want to find the maximum sum, so we just use the 6 plus 5 plus 4. And for edges, we can see 2 faces, just use 6 and 5 here. For those on the faces, just use the 6. So now we just use so this is 15 times 8, right? 12 times 11, 6 times 6. So you say 288. So even if it's the first time you see it, even if you didn't do the past year's paper, right? It should be a easy question. Yeah, it's also an easy question, right? Okay, so then the question 14, how many positive integers? So now x over 3 and 3x, both 5-digit numbers. So which means the smallest one, x over 3 should be at least 10,000. But the 3x should be at most 99999. So now we can get the smallest value for x is 30,000. The maximum value is 33333. So x must be a number between the range of 30,000 to 33333. But then also we should notice that this fraction is an integer, which means x must also be a multiple of 3. So we just need to count how many numbers between this range is a multiple of 3. So generally speaking, we just use the maximum value minus the minimum value divided by the common difference. If you list up all the multiple of 3, so every 3 number we have 1, and then plus a 1, right? So this is the final answer, is the 11112. So I don't know if there is anyone's answer is 33334 for this question. Yeah, anyone get the 33334 for this question? Then you just miss this condition, right? Generally, it's an easy question. Yeah, generally it's an easy question. Okay, so 15 is easy. 15 is easy. So we want to find the area of the ratio of the shaded region and unshaded region, right? So then we just calculate the shaded region. So shaded region can be divided into, you see this is 3 semicircle, right? So now now the shaded region, the 3 semicircle here, the radius is the 1, and then so it's the 3 over 2 times pi times r squared. So this is this region. And then for the blue region, on the other hand, you got 33334, right? So I know there must be someone who gets 33334. Okay, it's predictable. It's predictable. So there must be some student gets 33334. Teacher Turner would be mad at you, maybe. So since you already failed him once in the last week, right? Teacher Turner would be disappointed. Okay, so for the blue part, actually it's the difference of the 2 semicircles. We don't need pi. So the large semicircle is 4, the small semicircle is 3. So now it's the half times pi times the large one minus the small one, the square difference, right? So this is 1, and then this is the 7, so 3, 7. So now adding together is 5 pi. So shaded region is 5 pi, and then total would then be pi times 4 squared is 16 pi, and so the blank is 11 pi. So the ratio of the shaded and the unshaded is a 5 to 11. So now this is the answer is 16, right? The answer is 16. So now the problem for this question is that, so actually you don't need to calculate. You don't even need to calculate, because you know that shade to unshade, the ratio here, right? So the shaded part plus the unshaded part is the total area. Total area is 16 pi. So now we want to find the sum of the 2 parts. So it must be a 16. So I don't even bother to calculate. I just find the total area is 16 pi, so just the answer is 16, right? So we don't even need to calculate it. Right. Okay, so easy one. And then, so question 16. So how divide 9 students into 3 groups, 3 students in each group. So this question is not difficult, but it's very easy to make mistakes. So maybe I suppose it to be normal one. So any student get the answer with 9C3 times 6C3 times 3C3. So anyone get the answer for this one? This is not the final answer. But many students may just reach this answer, 9C3, 6C3, 3C3. This is wrong. This is wrong. So the problem is, so now every group has exactly 3 students. So which means if you make 1, 2, 3, 4, 5, 6, 7, 8, 9 in this group, it would be the same thing. It's the same thing like if we put the 4, 5, 6, 7, 8, 9, and 1, 2, 3. Right? This 2 grouping is exactly the same thing because the same group can change the order for each other. So now we should remove this order for their internal exchange. So we should divide a 3p3. So this is called the inner order. We should remove this inner order. Okay, right. So you forgot to put 3C3. Hey, 3C3 is 1. It's okay if you didn't put 3C3. It's the 1. But you need to divide the 3p3. So that's more important, right? So the answer is what? What is the answer? I don't want to calculate so large number. Now let me check what I've done. 280. Yeah, 280. So this question is very easy to make mistakes. So it's easy for you to forget to divide the 3p3, the inner order here. So because the 3 groups, they are the same, right? The 3 groups are the same. So you should remove the inner order for the same group, right? Okay, very easy to make mistake. So I treat this as a normal question instead of an easy one. Yeah. And then the question 17, this question is tricky. Actually, it's an easy one, but it's a little bit tricky. A number is co-prime with exactly 1 of 20 or 25. So it's either co-prime with 20 or 25, but you should notice that 25 only have the prime factor 5. And if this number has a prime factor 5, this one is not co-prime with 20. So this one cannot be a, so now 5 cannot divide this number. So this number must be co-prime with 25. So now if it's co-prime with 25, it cannot be co-prime with 20. So which means, so it's not a multiple of 5, but it's not co-prime with 20. So they must have the prime factor 2. So actually for this one, we need to know that, so this number must be a multiple of 2, but not a multiple of 5, right? So then how many numbers are there? Less than 2025, just starting from 2024. So first, the multiple of 2 is the 2024 divided by 2 is the 1012. But then we should remove those who are also multiple 5, which means we remove the multiple of 10 out of it. So now 2024 divided by 10 is 8202. So just a 1012 minus 202, so which we get a 810. Yeah, this is the final answer. Yeah, it's easy, but a little bit tricky. So you just need to know that 25 is special. So it cannot be co-prime with 20, but not co-prime with 25. Right? So just the multiple of 2, but not multiple of 5, a basic inclusion and exclusion. Right? And then the question, 18 is difficult. 18 is difficult. So 18 is an indefinite equation, but generally you cannot solve this one. You cannot solve this one. So someone says that the 17, it says that the either one of, so the either one of, or exactly one of them. So, what's your memory? So is the question asking for exactly one or either one? It's either or exactly one. I don't know what is the exact description here. You get 809, so who to blame? You get 809. So tell me who to blame if you get 809. So where did you, hey, where did you get it wrong? I just don't know. I just don't know that. Yeah, it's either exactly or either one. Never mind. So Someone says it's either one. It's exactly. But generally, if you see the either or, yeah. No. Maybe go to the question. Yeah. So go to the question 18, maybe. Go to question 18. Right. So the question 18 is hard. So we have the 17 folder, maybe the folder price is X, pen is the Y, eraser is the Z. So 17X, 25Y, 19Z adding together is 25. And then, so 23X, 21Y, 31Z equal to what? 36, right? So now we get this expression, and obviously we cannot solve it out, since obviously it cannot all be whole number, right? The price is not a whole number. This is the problem. The price is not a whole number. So now it's just not like just solve this expression to find the answer, right? Okay, then you can cancel out a Z to find some X and some Y, but still X and Y may not be whole numbers, so you cannot just solve it out. You cannot just solve it out. So there are two ways for you to solve this question. So the method one, I think the method one might be easier for most of you. So since we cannot solve for the X, Y, and Z, we want to get the expression with what? 56X, 108Y, and 52Z. We want to get the expression of this one, right? So the method one is a very tricky one, but it works. So obviously, all the value of X, Y, and Z would make this happen. So now the method one is to make Z equal to 0. So is it possible to suppose, so we just give the value 0 to Z, right? We just give the Z to be a 0. Then we can solve the X and Y. And then, and then we just use the X and Y to bring that to find out the answer, right? So now this is the first way. This is the first way. And then the method two, right? This is the, as I to say, is the correct method. But then, so this is something that a primary school student might not be that easy to solve it. So now we have the equation 1, we have the equation 2, and we want to get the equation 3. So we must have 1 and 2. We must find some way to make 1 and 2 into the 3. So what is this way? So now we can suppose that we use the first expression for A time, then the second expression for B time, and then we get the final expression 3. Right? Okay? Right? So we suppose that, so we use the first expression A time, second expression for B time, we can get the third one. So now, so if this thing works, then all the coefficients before X and Y must be the same. So the coefficient for X, we use 17 for A time, 23 for B time, will then equal to the 56. And then also, for Y, we have the 25 A time, 21 B time should equal to 108, right? So now this is the expression. So we can solve out this A and B to find out how to combine 1 and 2 to be the 3. So now this is some method very commonly used in the secondary school. So it's called the indefinite coefficient method. How to spell coefficient? It's very common used in the secondary school. But for primary school, right, it's not that quite common used. Never mind. So now we can find out that, so you solve this one to find, I remember A would equal to 6 and B equal to -2. So -2 means we minus it. So which means, so we use the first expression for 6 time, then the second expression for 2 time, we would always get the third expression. Okay, so now we know how to combine it out. So the final value would also be the value of the first one times 6 minus the second one times 2, so which is a 78, which is 70. So this question is difficult. This question is difficult. So in the indefinite coefficient method, it's not that common thing in this primary school. But you can find a similar question in our guidebook. So if you do the guidebook paper, right? So Yeah, I don't know how to spell coefficient, of course. And my English bad. My English bad. So if you don't understand, it's okay. It's okay if you don't understand. So if you are from a, if you're just a CO student, right, it's beyond CO student level. So then question 19. 19 is easy, but 19 is not that easy question. I think it's a normal question. It's a normal question. So now we have the rats, and then we have the squirrels, and the rats is 94 and decreased by 3, 91, 88. And then the squirrel would then be the 49, and then 51, and then 53. Right? So you want to know if you calculate the sum of the rat and squirrel one by one. So when will the squirrel sum overtake this rat sum? But then the problem is, if you express the sum, this expression would be a little bit more difficult, but I think it's okay. So now, because if you get the end state, so imagine we have the first day, second day, third day, and then we go to the end state. So now at the end state, we should have the rats who then have the 94 minus 3 times of n minus 1. This is 49 plus 2 and n minus 1. So this is expression. So now the sum of the rats, so it's the first term plus so now it's the 94 plus 94 minus 3n plus 3 times half times n. So the sum of the squirrel is the 49 plus 49 plus 2n minus 2, right? And then times half times n. So notice that the number of terms is exactly the same, right? So this is the method 1. Yeah, the method 1, right? It's just use the sum. We express the sum, and we notice that the number of terms is exactly the same. They're all n. And then all the half is the same. So now if the squirrel larger than the rat, we can get, so this is the 96 plus 2n should be larger than this 191 minus 3n. So then we can get the 5n should be larger than, this is a 95, right? So n should be at least 20. Yeah, n should be at least 20. So now this is the first way to do it. Get the expression of the sum, and then use the sum expression to get range of the n. Notice that the number of terms is the same, so we can cancel it out, right? But then we have a method 2. The method 2 is use the midterm. Use the midterm instead. So I think midterm will be faster for you to find out the answer. So now we should notice that, right? So the rat decreased by 3 and the squirrel increased by 2. So now each time their difference will then reduce by 5, 5, 5, 5. So now when will their difference become the same? So we should notice that on the 10th day, it's easy to find out. So on the 10th day, so both the rat and squirrel have an equal number, so which is the 10th day is 18, so 67, right? So the 10th day is to make them all equal to each other. So we name this as A10, maybe the red 10, right? So the red 10 and then the squirrel 10, right? So the 10th day, they're equal. And then, so now if we use this 10th day, we have 51 at first. 51 at first. Are you sure? Are you sure it's 51 at first? I don't know. The number might differ. So, but but I think 49 makes sense because 49 can make an exactly value here. I don't know. Yeah, never mind. So so anyone remember the correct number? So the number might be different, by the way. It's 49, right? It's 49. Yeah, okay, it's 49, then 49. Yeah, so the version I received is 49. So it should be 49. Right? So No, never mind. So now go back here. So we know that at 10th day, they have the same number. So now, which means if we put the 10th day, yeah, so if we put the 10th day in the midterm, so we should know that, so from 1 to 19, and the sum of square from 1 to 19 should be exactly the same because the midterm is the same. The number of terms is the same. So the first 19 term sum should exactly be the same. So the first 19 sum is the same. Then when we're, so now if we adding one more, then should be smaller because the red is decreasing. So the answer is 20, right? So also you can use the midterm to solve it. You can use midterm to solve it. So should it be easy or normal, by the way? Should it be easy or normal? So maybe we put a normal here. Due to respect, it's 19 anyway. It's the last two questions of the, you know, the 5-point question. Maybe a normal, maybe a normal. 20, I just wonder if 20 is difficult or normal, but if you remember, so, right? So in our class, I tell you one method to solve all this type of the 4-color problem, the coloring problem. So it's just to use the, you know, the president, council, and then citizen logic. Remember that. So which means we just find one grid which is surrounded by most others to make it into, right, the president. So in this case, maybe choose this one or this one. Maybe it's the same. Maybe it's the same. So now we call this one the president. Yeah, so grid A is the president. And then all the grid around the president, we call it the council. So this is B, C, D, E, right? We call this one a council. And then the last is this region, so the FGH. We call it the peasant, or maybe the citizen, right? Citizen to be more accurate. It's not peasant anyway. Okay, so and then so first we start with the president. The president A, of course, we have 4 ways to color the president, right? And then we go to the B, right? We go to the B. And then for this rounded B, the B, C, D, E. So B, C, D, E all together. So you should find out that the B, C, D, E actually, they made a 4-grid ring. And then how many colors do we need to use? We have 3 colors. If we want to color a 4-grid ring in 3 colors, then we can use the pathing ball method to solve it. Right? So suppose the 3 colors is the R, G, B. And then we start with the region B, C, D, E. We randomly gives a starting point here. Oh no, this one is. Suppose we start with the red, right? And then, so now pass the ball to 1, 1, and then 2, 1, 1. And then we have the, so this is the 3, 3, 2, right? 3, 3, 2. Okay. Oh, my calculation is wrong. No, my calculation is wrong, I remember. So, oh, my calculation is wrong for that one. So it's 3 steps, not 4 steps. So now I need to change it. So the question 20 is wrong. So maybe I change it afterwards. So I just calculate these problems in 1 hour or so. And then, so you should find out that the total method here, so the total method here, so it's the 3 plus 3 times A3. So we have a 27 ways. So we have the 27 ways here, right? We have 27 ways here. And then, so then for the FGH, would then be a, so you see, we start from the center G. So G is different from B and E. So G have 2 ways. So F have 2 ways. And then the F is different from B and G. So 2 ways. H different from E and G is 2 ways. So now it's the 2 to the power of 3 is 8 ways. It's 8 ways. So now the final is the 27 times 8 times 4, right? So which should be a, what, 768? 768? I suppose it's the correct answer. No, it's not 768. It's not a multiple of 27. Here you are. Oh, Oh, no, this is 18. This is 18 times 18. Then 18 makes sense. 18 makes sense. 18 times a 32. Yeah, 18 times 32. But still, I don't think the answer is, I don't think the answer is 768. So the answer should be, if my calculation is correct, so it should be 18 times 32, 576. 576. Yeah, it is correct. How many check it? For companies, I'm not so sure. So I know that I made the calculation error. I realize I made the calculation error in the slide I gave you, but is this one correct? 576. I suppose so. I suppose so. Right. So maybe this is a normal question. Yeah, the covering logic. It's not that easy. You should find the right order to do it. But it's not difficult anyway. It's not that difficult. So generally, this is the final. Yeah, this is the last question of 5 points. And so now we can go to the 6th point. Oh, the first question, you see square root. You got 384. That's 384. That's still not the same. Still not the same answer. So I suppose this is correct. I suppose this is correct. Right? So now for the question 21, you know what's the meaning of a square root, right? So this is easy if you learn the secondary school. If you learn the secondary school, so it's easy. If you didn't, it's difficult. It's 5 colors here. I don't want to change it. I don't want to change it. So it could be 5 colors. I don't know. But the problem is, so you just use the same method. It's not different. It's actually the same logic, right? So it's 4 colors or 5 colors. It makes no difference. So this method is correct. So if you remember it's 5 colors, then it's 5 colors. Never mind. So now we want to find the length of this AB. So how to do this? So we know this is 20, this is 20, this is 20. And then, so also we know this is 60 degree, 90 degrees. So this angle is 150, 150. So this angle is 30 and 30 degree, right? So we find the angle here is 30 degree and 30 degree. So now we see the 30 degree, we want to find length of AB. We can just draw the perpendicular line to do it. So now we just draw the perpendicular line here and here. Now, obviously, this is rectangle, so this one is 20. In the middle is 20, right? And then for this triangle, so we should notice that this is a 30, 60, 90 triangle. So now the angle opposed to the 60 should be a 10, right? Here we should have a 10, right? And then point A is on another square? You mean here? You mean this is the A? You mean this is A, this is B? I don't know. So I just based on my version. So this is one version given by one source anyway. So if you don't have strong proof for it, so if all of you say that it's wrong, maybe I change it. But if only one says wrong, I believe this might be correct. Or maybe just go through here. So because if it's here, this question would be make it more complicated than ever, right? So of course, this one is easier for you to calculate. It's more like a primary school question. If I put A on the other side, it will be seems to be a secondary school question, right? So now, if in this right angle triangle, this is 10, and then this is 20. So now this one would then be 10 root 3. So we know that for a right angle triangle with 30 degrees, it's always 1 to root 3 to 2. This is common sense, right? Okay, so if 2 of them say it was not, and you say it was, and also I received this paper, so now it's 3 to 1, right? It's 3 against 1. I believe it's 3. I believe A is just here. I believe A is just here. Okay, so now you see that, so this is 10 root 3. This is also 10 root 3. So the total distance would then be 20 plus 20 root 3. But in this time, we want to make the A plus root B. So we should times this 20 inside the square root. So now 20 times inside this 20 squared. So now it's 20 plus 1220. Sorry, 1200, right? So now the A is 20, B is 1200, so it's 1220, right? It's the 1220. Okay, so that's 21. It's normal or difficult? I think it's normal. If you learned about it, it's normal, right? It's not that difficult. But if you didn't learn about the square root, you didn't learn about this one, then it's a difficult one. So I think still it's normal. It cannot be a difficult question. So if you don't learn it, you don't know how to do, it cannot be difficult because you failed because you didn't learn. It's not a difficult question. The difficult question is you learn it, but you still don't know how to do it. It's a difficult question. I suppose this is a normal question. Question 22. So we have two number pair A and B. So one number is between 25 to 28. So if we suppose this number is A and, so we suppose that the number group is A and B. So A then equal to 25 to 28. And then what is the range of the B? What is the range of the B? So now, because one number is at least 25% of the other number, so now B is at least a quarter of A. And it's at most 4 times of A. Right? So generally, we can have the value for A equal to 25, 26, 27, 28. So now we have there's 4 numbers here, right? We know there's 4 numbers here. So for 25, right? For 25 is B then equal to, starting from 7, right? The smallest value for B is the 7, and to, what the largest? 100. And this is 7 to 104, 7 to 108, 7 to 112, right? So how many numbers do we have? We have 94 number here, 98, 102, and 106, right? So now the answer would then be adding them together, 94, 98, 102, 106. So this is just a 400. This is 400. But 400 is not the answer. 400 is not the answer. Do you know why? Because there are some numbers, there are some pairs we counted repeatedly. So now we suppose that A is 25, 26, 27, 28. So is it possible that B is also 25, 26, 27, 28? Of course it can be, right? Actually, so 2 numbers among 25 and 28 satisfy all the conditions. And so now, for example, the 25, 26, right, is counted both in the first condition and also in the second condition, right? We double count the stops. So how many stops are there? So these stops, they're all made by, you see, they're all made by one number starting with the, right? So you see that this number, one of them starts with 25 to 28, another is another number 4. So it's the minus 4 times 3. So why don't we minus 4 times 4? Because 25 and 25, actually, this one is not counted twice. This one is only counted once. Yeah, this one only counted once. So it's only in the 25 group. But 25, 26 is counted both in 25 group and 26 group. So we should minus the extra. So the answer is the 108. Sorry, not 108, it's 388. Right, 388. Or maybe normal question, very easy to make mistakes. Yeah. 23 is an easy question. Yeah, I suppose 23 is an easy question. So from the 1 to, so which numbers directly below the 2025? Maybe we should find the position of 2025 first. Notice that they're all odd numbers. So first, we should determine position of 2025, which is the 1013. It's, no, it's like this. So it's like this. And then, so it's the 1013th position, right? This is 1013th number. And where is this number? So we know the first row have 1 number, 2 number, 3 number, 4 number, and 5 number. Then which means we need to find, so now, which triangular number is close to this 1013? And so there's some way for you to estimate it. So 1 to 2 to n. equal to half times n plus 1. So if this one is close to 1013, and then n times n plus 1 should be close to 2025. And this is quite obvious for you. It's at 44 times 45 and 45 times 46. So now which means 1 to 44. Right? So now this one is half times 44 times 45. So obviously this one is smaller than 1013. But 1 to 45 should be larger than this 1013. Right? So now we know the thing. So now we know the position is that the first 44 row is not enough and 45th row is enough. So now we know that this number, so 1013th position is at the 45th row and at some column. So you can find which column it is. You can find which column it is. Because you can use the 1013 minus this 990, right? 1013 minus the 990, so which is a 23. So it's the 23rd column. And then we want to find the number which is the 46th row and then 23rd column. So now it's just the 1 plus 2 plus 45, then plus a 23, right? Or we have an easier way. We simply just plus a 45 to 1013 to find the answer, because you see that 1013 is here, right? And then we just, this is the 45th row. And we go to the 46th row. So the number we need to go through, right? You see the number here. We just go through all the number behind 1013 and all the number in front of it. So it's just we count additional 45 numbers, right? It's just count additional 45 numbers here. So which means we can just use this one to simply plus a 45 to reach the answer. So which is the 1058. But 1058 is not the answer. It's not the answer because this is for the 1058th number, right? So this is the 1058th number. And what is the 1058th number? So it's the 1058th odd number. So which means we can just use the 1058 times 2 minus 1 to find out the answer. 2115 is correct. The 2115 is correct. 2115 is correct. Because you count 45 number behind, you just plus a 90 to 2025, right? You see, yeah, this is correct. This is an easy question. This is an easy question. Question 24. Question 24. So this one is easy or difficult. And it's not difficult, it's easy or normal. It's easy or normal. So it says that we have a rectangular piece, right, whose length is twice the width. The length is twice the width. So now it says, so now we can assume that the length is 2u, and then the width is the u. So the area is the 2u squared. Originally 2u squared. And then it also equal to the length increased by 40, and then width decreased by 2u plus 40. And u minus, no, it's 2u minus 40 and u plus 8. Right. And then area is the same. Then we solve out this u. So don't be afraid. You see that u times u, you can cancel it out anyway. You open the bracket, or maybe you cancel out 2 first. So u squared equal to u minus 7, u plus 8. So this one would equal to u squared plus u minus 56. And that's quite obvious that u equal to 56. Now if u equal to 56, and then so the original one is the 112 and 56. Oh, might be. The question is actually for the new, it's new pieces, right? It's new pieces. So maybe we just calculate the new one. The new one is 56 minus 40 plus, sorry, it's 112 minus 40, new parameter. 112 minus 14 plus 56 plus 8, right? And then times 2. Don't forget the times 2. So what is the final answer? What is the final answer? So it should be 324 is 324. Yeah, 324. This is easy. I suppose this is easy. This is easy. So this is question 24. And then we go to the question 25. Are you familiar with the question? So I suppose that we talked exactly the same question in your training camp. If you remember. And then also, right? So if you see that I gave you a paper about 50 questions about Q025, I also put this question here. Remember? Right? So if you remember, then this question is quite easy. You even actually remember the answer for this. So generally speaking, you want to find a number that is made by, right? So the two of them is the same. So the easiest, so now this is a normal question. It's not that easy. It's not that easy. So now maybe we should use the so now the easiest way is that, so now we use the AABC, right? So we use the AABC. And then, so first, we determine the position of A and A, right? The position of AA, we have 4C2, we have 6 ways, right? We have 6 ways to determine this AA. And then after that, right? So now we have AA, B, C, we have 6 ways for the AA. And then where do we put the B and C? Where do we put the, so now this doesn't matter. And then after that, and the choice of numbers, right? The choice of numbers. So now we assume that is 3, so now it's maybe the A, B, A, C or something like this. So now we have 3 numbers to choose. The first number cannot be 0. The first number have 9 ways. And the second number also have 9 ways. It's different from the first one, but it can be 0. And the third number have 8 ways. So it's the 9 times 9 times 8, right? So 81 times 8 is a 648. Yeah. And then, so the total method, we determine the structure of this number, and then we times the choice of the number. So it's the 3888. This is the easiest way to reach the answer. This is the easiest way to reach the answer. And then, so, but, right, so you can just discuss about the zeros because 0 is annoying. You discuss is 0 or not, or you can just discuss about is the AAB, so it's the AABC, they both know 0, or maybe AAB 0, or maybe AB 0, 0. You can classify into 3 different cases and calculate it. It's still the same thing. It's still the same thing, right? But this way is easier for you. Just, you can ignore the zeros influence. You just put the order of the 2 same number at one place, and then decide all the others. Oh, wow, it's a disaster, question 26. So now the question 26, this is the hardest question. This is a very hard question. So I label difficult here. I label difficult here, the list. So now it says that, so we have the 2 times 3 cards, and then, so one face is white and one face is black. So now how many different ways are there to make a rectangle? So now if it's rotate or flip to be the same structure, it should be the same. So now we should notice that, so now we have 6 grid. So there should be, could be all 6 black, or 5 black, 1 white, or 4 black, 2 white, or maybe 3 black, 3 white. Right. And then, so the problem is, so you should notice the thing is that if we also have the 4 white, 2 black, 5 white, 1 black, or 6 white. So generally speaking, so this must be the same. Because you flip a 4 black, 2 white, you can always get a 4 white, 2 black. So which means we don't need to count this 3 stuff. We only need to count 1, 2, 3, 4. We count the 4 kind, right? We just need to count this 4 kind. So now we only need to count this 4. Right? We just count this 4 to find the answer. And it's not that hard to list. It's not that hard to list. I think listing is okay, but in listing, you know that there is very troublesome stuff. Yeah, so I tried the listing also and find out if you do the listing, it's very easy for you to make mistakes. Now let's start to so now if it's 6 black, we start with 6 black, maybe 6 white. Never mind, so maybe 6 white, 6 white. So or 6 black. Only one way. Of course, it's only one way. We don't need to discuss about this. And then for 5 black, 1 white. So generally speaking, this black can be put everywhere, but this picture is symmetric. So now this region, right? So now this one and this one is the same, right? So this one and this one is the same. But then I have to say, the very troublesome thing is that you should notice. So of course, these two are different. Of course, these two are different. So tell me, is the first and the third, are they same or different? The first one and the third one, should they be the same or different? Actually, they're different. Actually, they're different. So you may think, hey teacher, we flip it, it should be the same. No. If you flip it, you make it into a 5 white, 5 black, 1 white instead. The 5 white, 1 black instead, right? So the color is not the same. So you cannot flip the first one into the third one. It's not. So the first one, third one, actually, they are the differencing. Actually, they are the differencing. That if you have 3 ways. Yeah. So now this should be 3 ways. So which means actually is or we have another way is the 6C1 divides 2. So because we have 6 places to choose, and then each place we can rotate to have the exactly same position for it, right? We can rotate, but we cannot flip. We can flip here to be a different thing. So now it's easier to find the 3 ways here, right? I just draw it, and then if you have 4 black, 2 white, so generally speaking, right, there is something. So totally, if you regardless of the flipping and rotating, right? You forget about this stuff. You forget about this stuff, right? So now in this case, we should have 6C2, which is a 15 ways, right? We should have 15 ways. But then in this 15 way, of course, everyone can rotate 180 degrees to use, for example, this one can rotate into this one. They're the same. And also maybe this one, rotate 180 degrees to be this one. So these stuffs, they are the same, right? Of course, they are the same. They are the same, right? And after that, so if every one is counted twice, can we just use 15 divided by 2? Of course, it's impossible because 15 is not a multiple of 2. Why is that? Because there are some stuff that when rotated is exactly the same shape as previously. So now we have the 3 specials. So now we have the 3 specials here. We don't draw all the things. So now we have the 3 special one who rotate 180 degrees, the same thing. It's same as usual. So now it's this stuff, and this stuff, right? So these 3 stuffs, they have exactly the same when rotate 180 degrees, which means they are not counted twice. They are only counted once, except for the 3. All the others is counted twice. So which means we can just use we have 15, except for the 3. Everyone is counted twice, but this 3 is only counted once. So we should have 9 ways here, right? We should have 9 ways here, right? We should have 9 ways. And then if we have 3 black, 3 white, so generally, again, if we ignore the rotation and flipping, it's the 6C3. We have 20 ways. We have 20 ways. And then among these 20 ways, again, 3 is an odd number, so there's no structure that is rotated 180 degrees to be the same thing. So each method should be counted twice. Now when divided by 2. So now this is 20 divided by 2, we have 10 ways here. Right? We have 10 ways here. I don't, I don't draw out all the shapes, but you can see all the shapes. I draw it in the slide I gave you previously, right? You can see that version, right? I draw out all the different shapes also. But actually, this calculation is easier. You don't need to draw out everything. In the real test, I don't think you have enough time to draw out everything. So this is the total method. So in all these 4 kinds, so 1 plus 3 plus 9 plus 10 equal to 23 ways. So this one is difficult. And do you know, when you draw out the picture, do you know what is the most frustrating part? So I draw, in the 4th case, I draw 2 shapes for you. One is like this. One is like this. So tell me, is this 2 shape the same? Or is this 2 shape different? So, unlike the previous ones, the previous ones cannot flip because we have 2 to 4 and 4 to 2. Flip, the color is different, so of course we cannot flip. But can we flip this 2 to be the same? Because now we have 3 white, 3 black. When we flip it, it's also 3 white, 3 black. Right? So can we flip this? Can we flip this shape? So actually they are different. Actually they're different. So if you flip it, you should find out that this one, the left one, you flip it, it's still itself. It might be hard for you, but you should know a thing is that the other side of black is the white. The other side of the white is black. Yeah, these two, these two can rotate. It's not flip, it's rotate. So what is the flip, I mean? Right? No. I need to show you something about flip. I remember there's something that you can flip. Yeah, it's not this one. These two are symmetrical. So maybe I should show you 2 different things. These 2 can rotate to be the same. These 2 can be rotated to be the same. Yeah, it is true, it's true. But then what about this one? Yeah, I mean this one. This one. Yeah, might be. Yeah, the example should go like this. Yeah, these 2 are different. So it seems that you can flip, but if you flip, right, actually it's the same thing. And no, it's not the same thing. So they are different. Yeah, might be. Yeah. So I give you a wrong example. So I just give you some symmetric ones. Yeah, I mean this 2 shape. Right, so it's not that easy for you to figure out whether they're the same or different. Actually, they are the different stuffs. They're different stuffs. So yeah, this is very frustrating actually. So question 20. Flip then rotate. You try it, it's impossible. So if you flip and rotate, still you cannot get it. You try it, you find it out. You cannot get it. So the question 27, this is something like the number puzzle. Yeah, we can use number puzzle to solve it, actually. It's too long. This question is too long. So it's not that difficult. It's a normal question, maybe. It's a normal question. It's not that difficult. So then the 27, we have a 4-digit number A, B, C, D. And then we plus a 9 to it. So yeah, you try it, flip and rotate, and you find they're still not the same. You try it, still not the same. Okay, so question 27. So now it says that the flip and rotate. Hey, wait for a while. What about flip and rotate? Flip and rotate. The problem is if it's flip and rotate, then the answer is wrong. Yeah, you're correct about this one. What if we flip and rotate? We flip it here, so it becomes when we flip, it becomes this one. Wow, that make the thing totally different. Hey, no. That make this thing a little bit different. So if we can flip and rotate, yeah, you're correct. If you flip and rotate, then it's not 10 ways. So I suppose it's not 10 ways because all the 10 ways, they're not the same thing. If they're not the same thing, then because in this 10 ways, I only treat this 2 as the same thing. No. I only treat this 2 as the same thing. So no, you are correct. Well, then just make this question more complicated. For 3 black, 3 white. So yeah, we can flip and rotate. Yeah, you're correct. We flip and then we rotate. Then which means we cannot use the formula to solve it directly. Right? So I need to change to. Oh, I also made this question wrong. Yeah, it's difficult. Of course, it's difficult. So then we have no way but listing them up. Well, I hate that question. If we must list them up. So if we can just directly use this rotating, just repeating method to use it. We can obviously list them, but the answer is not 26. The answer should be way smaller. But I hate listing. Then maybe try to list. So if we list it, so now it's 3 black, 3 white. So we just discussed about the 3 black, 3 white. Should they be at? So if they are all in the different column, so we can have the first one is like this, and then maybe like this. So we have this 3 1, right? We have this 3 1. So then the problem is, yeah, let's see about this thing. Is this 2 the same? Or different? Is this 2 the same or different? I have a question. So now if we try it. So if we rotate this one, no, we flip this one first. We flip this one. No, this one, when we flip, it's the same, right? It should be the same shape when we flip it. It should be the same shape when we flip it. And then, so when we rotate, it makes no difference. So now it should be the same. No. These 2 are different. You cannot make, you cannot make this 2 overlap. Because if you flip this one, you see, it's still the same thing. After flip, it's still the same thing. And you rotate, right? We flip this one, it's the same thing. Unlike the previous one. The previous one, you flip it becomes a different thing. But for this one, flip it, it's the same thing. If you notice that, it's the same thing if you flip it. And the 2 shape we talk about here, right? For this shape, you flip it, it becomes a different thing. You flip this one, it becomes like this. You flip it, it becomes a different thing, actually. Right? Actually, these 2 are different, right? So these 2 are different. We flip it, it's not the same, right? So, yeah, so we have 4, right? This is 4 kind we have. And then, so now this is all the row have the 1, is 1 plus 1 plus 1. And then the second is the 2 plus 1 structure. So 2 of them in 1. This one, yeah, then we talk about this one and this one, right? So we just talk about these 2 are the same, right? So we can flip and rotate to make them the same. I doubt for we need to check it one by one. If we flip this one, it becomes like this, and we can rotate to make it happen. Yeah, it's true. So they're the same. So this is the same. And then, so it should be the same logic, right? So, and then we have this one. So this one and this one is the same logic. When we flipped it, it becomes this. It becomes this one. I suppose this 2 is not. I suppose suppose this is not the same. This two is not the same, you see. So because if you flip it, yeah, you see, if you flip it, it's a brand different shape. It's brand different shape. But still, right? So you see that this two is the different, but they are the same with, they should be same with this one, right? They should be same with this one. Yeah, these two are the same, right? So these two, which two are the same? So we flip this one. So we flip this one to make it to be black, black, black. So you see, these two are the same. Wow, these two are the same. These two are the same. Okay. Okay, these two are the same. So then how many kinds do we have? For 2 plus 1, if the 2 is in the middle, then we just draw out everything. So which means we only have 7 instead of 10. So we only have this 7. We don't only have this 7, which means because these two are the same. So it should be 7. It should be 7. I don't know. Let me check if these 7s are different. If the 7 are different. Yeah, obviously this 7 they are different, right? Obviously this 7 are different. So we cannot use rotation or flipping to make that the same. So now they are different. They are different. So now we have 7 ways instead of 10 ways. Yeah. So we should consider some extra cases about flipping. So totally we should have 1, 3, 7, 9. 1, 3, 7, 9. So which is a 20 ways. 20, right? So this is the only case that we could have the problems, right? So this is the only case that we could have the problems. This is about question 4, right? Okay, might be. I thought it's, so I think it's too easy. I think it's too easy. So just about, yeah, I just think about flipping. So I thought that flipping won't make that the same. But then I realized that rotate then flip. Yeah, it's just Johan is correct, right? So about flip and rotate can make something the same. But then we have 3 more cases which should be the same. Well, it's hard. Okay, we go to question 27. Finally, we go to question 27, right? So for question 27, where are we? So now it's the A, B, C, D. The plus a 9. Right? So now we know that when a number plus a 9, if the last digit is 0, then it has no carryover. Otherwise, it will have carryovers. But obviously, this one, the normal case, it don't have a carryover. It's not 0, and we can show why it's not 0 here, right? So generally, if one number plus a 9, the structure would go for, we have a carryover 1 on the 10th digit. And then by the carryover is a D minus 1, right? So when we plus a 9. And then the second one, swap the last 2 digits. So make it into a B, D minus 1, C plus 1. And the third guy swap the first and the third digit. The first and third digit. So make it into first and third. So it's the D minus 1, B, A. C plus 1. And this number times a 2 to be back to the ABCD. Right? And then we don't use times a 2. Times a 2 is too hard. But we can, times 2 is plus 1 number by itself. So which means we can use the addition to make it easier for us. This 2 number adding together makes it an ABCD. Right. So that's why I say that why D cannot be 9. Because if this is 0, then this is the 9. And then 9 should be swapped here. But obviously 9 cannot be swapped here. The first digit cannot be 9. 9 is too large, right? So now the last digit is not 0. So we can be sure that last digit is not 0. So the number should go this way. And then after that, so how to find out the actual value of this? This is something like the number paddle we see in the primary 2 or primary 3. The primary 2 maybe. Right. So I think it's a normal question, but still, it's not that easy for you to solve it out. So principal point actually is here. So you see that C plus 1 equal to D. So D must be an even number, right? So D is an even number. And also D minus 1 plus D minus 1 equal to A. There's no carryover. Now D can only equal to 2 or 4. You see, D cannot be 6, or it's too large for A to be a 4-digit number. So D is either 2 or 4. And then it will be easier for you to find out the answer. So now let's just try it. Now if D equal to 2, and if D equal to 2, then C plus 1 plus C plus 1 equal to 2, we have two different possible cases. The first case is that C plus 1 equal to 1, which means C equal to 0. Or the second case is C plus 1 equal to 6, and then here is the 5. Let's try each cases. Yeah, just to try these cases. And then so we try if this is the 1, this is the 0, and A plus A equal to 0, and A is not a 0, so A must be 5. But then you see D equal to 2, so this is 1 plus 1. Can 1 plus 1 equal to 5? Not possible, right? So now, no. C plus 1 cannot be 1. Then let's try the 6. So if it's a 6 here, then we have a carry over 1. And also now C equal to 5. And then here 1 plus 1 equal to 2, obviously. So now A should equal to 2. Okay? And then there's no carry over here. B plus B equal to B. So the only possible is to B equal to 0. Okay? That makes the sense. So A, B, C, D equal to 2052. Yeah, 2052. You can try the D equal to 4. Yeah, there's no solution. Yeah, you just try it. Right? No solutions. So generally, it's not that difficult, right? Actually, a primary 2 student, if give him enough time, he can try and find out the answer. Right? We don't need to use some advanced strategy or something like this. But then, so that's 2052. No more question. Question 28. Should it be a difficult question or a normal question? It's not easy at least. Normal or difficult? Maybe I treat it as difficult. But actually, so remember the original question. If you did the AMC training, so there is an AMC 8 question about an octagon, the same model. I don't know if you tried AMC 8, right? And so this should be the, like this. And then, so it's easy. Yeah, 120. So maybe not difficult, maybe it's normal, right? Maybe it's normal. Maybe treat it as normal. So not that difficult, right? So now, in AMC 8, we have the octagon with the same question. So the problem is just, so how do we draw? So how do we draw an obtuse triangle? So actually, if you learn some secondary school stuff, it should be easier for you. In secondary school, you learn a circle, and you know that this is just about a chord thing, right? So now for this one, the logic is, if you want to draw an obtuse triangle, the thing you need to do is that, so first, find a random point, and then draw a random line from this point to any, for example, here, or here. They both should be okay. And then if we draw it, right? So we draw it on this side. You should find out an interesting thing is that, right? So now if we choose this point, right? So this is on this side, you choose a point on this side, and all this angle opposed to this side is obtuse angle. And so now if I try another thing, try another thing. For them here, and then we can find this angle, this angle, this angle, and this angle. They're all obtuse angles. However, if you try another side, you try this one, this one, this one, this one, like this. So the angle is all acute angles, you see, right? So you see that. So if you draw an obtuse triangle, so first, we find a segment. And then this segment divides the shape into 2 piles. And then we should see that angles on the fewer side, they're always obtuse. And the angles on the more side, they're all acute. Yeah. So now this is easy to prove if you learn sectors, you learn the circles, right? This is the circumference angle of a circle, right? But if you don't learn the secondary stuff, you don't know this, then it's hard for you to find it out. So now this is the way we find an obtuse angle, and each obtuse angle, of course, stands for 1 obtuse triangles. So now the logic is, right? So how many ways are there for us to draw the line? So generally, right, we find the segment. So now, the segment length determined by this line, right? So it cannot be 1, right? It's not opposed to nothing. So it could be, so this length just makes how many points we go through, right? Just we name it 1 and 2. So we label this length is 2, right? So now if we draw a line, the length is 2. It only opposed to 1 point in its fewer side. So 2. So we have triangle, or maybe the obtuse angle. We only have 1, right? And then if we draw this line, and then if we draw this line, 3 points on the fewer side. So 3. And then if we draw this line, 1, 2, 3, 4. So it's 5 and 4. However, if we draw this line, so we just draw the diagonal, things are totally different. So I would tell you that if you draw this line, all this angle here, they must all be right angle. They are all right angles. And all about this, because they have equal point on each side. So at this time, all the angle here, they are right angles. So now which means, so totally from 1 point, we can draw 10 triangles. And so now someone may ask, hey teacher, I can draw this one. But you will see that if you draw this line, right, this is AB. So it's counted as, so AB and AC. So generally speaking, right, this line is counted twice actually, both by AC and by AB. So to make it easier, we always draw the line on the same direction. For example, for this line, if we treat this line AB as the start, we start from A. And then for this line AC, we treat it starting from C. We always go, for example, we go a clockwise direction and don't pass the half region, right? So we only count 1. So for CA and AB, we only count 1 for point A and another belongs to point B or point C. So now in this case, in each certain length, we have 1 and only 1 segment on each segment. Or you can just times 2 and divide by 2. It's the same thing, right? So generally, we have 4 kinds of segments on each point. And totally, we can draw 10 obtuse angles. We have 10 obtuse triangles. We have 12 points. So the answer is 120. Yeah. So the MC8 have the same question. Yeah. So this is a normal question. So someone said it's easy. So it's not easy anyway. So maybe we treat this as normal. No, normal, to be fair. It's normal. 29. So 29, I have to say, if it's the first time you see it, it's a difficult question. But it's exactly the same question you see in the 2023 SMOPS. It's exactly the same question. And we run through this in our holiday camp, in the mock test, in many different places. So you should know that this question, right? This one should be easy if you did it before. You should did it before, right? Difficult if you don't. But you should did it before, so I should treat this one as an easy question. I should treat this one as an easy question, right? Original question is 7 times 7, this is 5 times 5, actually the same thing. So first, we want the sum to be divisible by 5, so we just replace every number here with their remainder by 5 first. So make it into a 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, right? And then, secondly, so now if you draw a rectangle inside, you should see that, so now each row have exactly the same number. So now, the sum of rectangle should equal to the sum of a row times the number of rows, right? So now in this case, we already did a multiple 5. We have two cases. The first case is to make the number of row equal to 5. We choose all these 5 rows to be its vertical side. And so now we can choose any horizontal side to make it rectangle. The sum is always multiple 5. So which means, so now we have 1, 2, 3, 4, 5, 6. We have 6 vertices. So now we should have 62 ways to determine the horizontal side. So we have 15 different horizontal sides. So now we have 15 ways to make a rectangle. Right? Okay. And then, so this is the first case. The second case is we can make the sum of each row become a multiple of 5. Or it's not exactly the 5, right? So the sum of row is a multiple of 5. Which means we just need to find, so how do we choose the consecutive numbers to connect in a row and then the sum is multiple of 5? So in this case, we have the 2 plus 3 is one case, 1, 2, 3, 4 also, and then don't forget we have the 1, 2, 3, 4, 0, and in the end we can use the only 0. So we have 4 ways to make this, to choose the row to make the sum of the row is a multiple of 5. And in this case, we have 4 ways here. And then, for example, we choose this one at the horizontal side. And the vertical side, we can choose anything we like. Then again, we have 62 ways to choose the vertical side. But the problem is, we counted all the cases that we choose all the rows in the first case. So in the second case, to avoid repeating, we should exclude those who choose all the rows for the vertical length become 5. So we minus the 1. We exclude this case which is counted previously, right? So now this is the 4 times 62 minus 1. So now is 56 ways, right? And then 50 plus 56, so should equal to 71 ways in total. Yeah. So now I have to say, so this question, yeah, if it's first time to say it, it's not that easy for you to solve it. So I suppose that 203, I remember no students solved this question. Yeah. But then, so in the, but this is the second time you see this question, so it should be easy for you, right? Should be easy for you, right? Okay. And then, so last question, hey, if you remember, so is there any of my ED students here? So this is exactly the same question we taught in our ED class. Yeah, exactly the same question we taught in our ED class. They didn't even change a word, right? So now, yeah, so we want to know that, so ABCD equal to AB plus CD squared, right? And then, so how to make it easier? So you can just try out all the possible cases. You can list up all the square numbers out, but it's hard, right? So now, to simplify it, we can use place value principle. A, B, C, D, we can write it into, first, slowly. So now it's the 100 AB plus 1 CD equal to AB plus CD squared, right? And then the right side, we have AB plus CD. So left side, we split one of the AB plus CD out. And then we move this AB plus CD to another side. And should equal to AB plus CD, AB plus CD minus 1. Right? And then look at this structure. It's easy for you to find out that, so the right side is a multiple of 99. So 99 is 9 times 11. So to make the product of these two numbers a multiple of 11, so now we have three cases actually. So the first case is that, so can we just make one of the number exactly being the 99? Actually, it's possible. So the first case is to make AB plus CD equal to 99 directly. And in this case, so ABCD, 99 squared equal to 9801. Of course, this won't work, right? This won't work. And the second case, you should know why the 2025 works, because here, so maybe one of them is a multiple of 11. For example, the AB plus CD is a multiple of 11. And then AB plus CD minus 1 is multiple of 9. So which means we need to find the two adjacent numbers. One is multiple of 11, one is multiple of 5. You can use the Chinese remainder theorem to find this number, or maybe just list. It's not that hard. List all the multiple of 11 to find out who plus 1 or minus 1 is multiple of 9. And then you find out this group is 55 and 54. So now 55 squared also work, which is a 3025. Yeah, this also work. In the third case is for, again, 11 divides the smaller number and 9 divides this larger number. And then this is the 44 and 45, which in this case is the 2025. Right? So these are the three numbers here, right? So now, except for 2025, we have two other numbers, the 9801 and then the 3025. Just adding them together, what is the final answer? 3025. So 128. 12826. 12826. Yeah. Okay. So this question is difficult. I think it's difficult the first time you see it. Yeah, it's difficult. Though I suppose that some students solve it out, but okay. Okay, that's all. Let's see. So how many easy and how many difficult questions are there? So we count the easy. No, we count the normal and we count the difficult. So all the others are easy, right? So normal 1, 2, 3, 4, 5 normal, 6, 7, 8, 9, 10, 11. Okay, so this question is between easy and difficult. Maybe treat as normal. So now 12. So now we have 12 normal. And how many difficult are there? How many difficult are there? How many difficult are there? 1, 2, 3. 3 difficult. Okay. And then 15 easy. Right. 15 easy. So then, again, right, my logic is slightly different from this question because we have 3 different questions. So I'll suppose that we have 80% correction rate of this 50. And then, so we have 50% correction rate for this 12. And then you get no difficult question correct, maybe. Let's suppose you get no difficult question correct. So which should be, or maybe I just give you a 20%. But I don't think the 3 difficult question you have 20% there, right? So maybe 20 times A3, right? 0.6. Terrible. No terrible. Maybe the question 26 is terrible because I also made mistakes. And there is no easy way for that question, only listing. I hate those only listing questions. We have 12 here, we have 6 here, and we have 0.6 here. So it's the 18.6 questions. So this is the estimation lines. So now the score of the for platinum simply times 5, 93. Yeah, this is my estimation. 93. Yeah, I think it's 93. So if you get more than 93, yeah, I think it's okay. Yeah, it's safe. 107, I think it's good. Not that good, but I think good for this paper. I think good for this paper. Okay. So you should get what about more than 90 questions correct, and maybe more than 20 questions correct, and then you get 93 more points, and you have a high potential for the platinum. That's my estimation. Okay. Do you want to listen to how to prove the question 5, by the way? Do you want to listen to how to prove the question 25? Maybe not. Maybe not. But you can try it. So make the proof of the question 5, maybe just the second round level. So the second round difficulty, just want you to prove it. It's not that I won't be so surprised if the second round asks you to write a working for this question. Right? But it's the second round stuff. So for the first round, maybe just stop here. Okay, that's all for the first 30 question. Maybe you can go now. Yeah. Okay, so this is the, how about gold? I don't know about gold. Because the gold generally means nothing. There are so many gold, and gold for small actually means nothing. Gold cannot enter the second round, and the HCI, they only want the platinum to enter the DSA. So if you only get the gold, you won't even be invited to the DSA anyway. Right? So I don't care. So I don't care actually. I don't care about the gold. So I don't know about the gold line. Yeah, sorry for that. Sorry. Yeah, there's a platinum. The platinum is the highest level in SMOPs, and only platinum matters. So only platinum can enter the second round. Only platinum can enter the second round. Yeah, we're done. We can go. Yeah. So we just wait here in case some students have problems. Oh no, my WeChat dropped. I don't know when the WeChat dropped, so I cannot see the questions on the WeChat. So distinction means nothing. The RMO distinction, like the SMOPs gold, generally that means nothing. Generally that means nothing. There's so many gold and so many distinction for those two competitions. So actually that means nothing. So only high distinction and the platinum matters, especially for upper primary students. Of course, if you're only P2, P1 or P2, you get a distinction in RMO. Is there really a guy? I think it's good. Okay, that's for today. Bye-bye.